It's Mr. Nieding, and we are going to continue with our review for the second examination, and we're going to pick it up in section P, probability section. So in this particular section, we're going to talk about the probability rules. Camera's going a little crazy there. So first one, P of A or B. If we're dealing with the probability of A or B, then we have the probability of A plus the probability of B, but we have to remember to take out that overlapping section of A and B because it gets double counted. I'm going to switch this camera real fast so it doesn't keep doing that, I hope. Second rule that we want to stick by is the probability of not something, not A, is the probability of 1 minus that same something. This will be a nice rule for us to utilize most of the time. Probability A if B. Well, the probability of A if B is the probability of A and B divided by the probability of the thing which happens second. Most often you will see me write this particular notation as the probability of A if given B, that little line there, okay? That's the same thing as saying if. And the probability of A if A, the only change here is notice that the A and B are the same, but the difference is probability of B division, probability of A division. It's the thing which comes second, or the thing that has to happen first, if you will, in order to get that calculation. And these are the ones that will be given on your examination, on your exam sheet, okay? So these are the ones you'll be given. Anything else is on you. And given these, you can come up with anything you need. Let's do the true-false first. An event is a subset of a sample space. Well, that's absolutely true because all of the sample space are all the things that can take place. And if all the things that can take place, this is one of those things, then this is a subset of this value. The probability of A is 0.7, then the probability of not A. Well, remember, 1 minus this should be equal to this, and that's not true here. It should be 0.3. The probability of A and B equals 0. The event A and B are disjoint. Well, they are definitely disjoint if there is nothing that happens in which they both take place at the same time. Remember, to be disjoint means that one cannot physically happen when the other one takes place. 0. The experiment is drawing a card from a standard deck of cards. The number of possible outcomes of the sample space is 52. That's true, because 52 different things can happen. We're not including jokers or goofy cards. The probability of event A is the measurement of the likelihood of event A. That's true. What is the likelihood that this will happen? That is the probability of this happening. Probability of A if B is the same as the probability of B if A. Absolutely, positively not. We have two separate formulas because these are two completely different things. Dividing by probability B and dividing by probability A when they are different is going to yield two completely different answers. This can't be true. Two events being disjointed and two events being independent are equivalent. Those are not the same thing. To be disjointed means you can't happen at the same time. To be independent means one does not affect the other. If I draw a card from a deck and then I go into my closet and pick out a shirt, the drawing of a card has nothing to do with the color of the shirt I picked from the closet. They are independent of each other. However, though, being disjointed, the two things cannot happen at the same time. I can clearly pull a card and then walk into my closet and get a shirt. Event A and B are independent if two events have no occurrence on the other. That's what I've been stating over and over. That's true. And if P of A and B, the overlap, is equal to just the probability of A times the probability of B, then A and B are independent events. And that's true. If I take whatever the probability of A is and I multiply it by whatever the probability of B is, and it's exactly the same as saying A and B, that means this one didn't affect this one and this one didn't affect this one. So they are truly independent of each other. So let's do question 20 here. And I think for most of these questions, I'm going to pull up. I have another piece of paper here also that I'm going to work from, that I helped to work out some things. So let's do number 20 first. So the two events, A and B, we have the probability of A is 0.47 and the probability of B is 0.33. A and B is given to be 0.20. Round your answer to 2 decimals. Okay. So what's the value of not A? Well, to do not A, I like to take 1 minus the probability of A. I know this is the probability of A. So 1 minus 0.47 is 0.53. To get the probability, and I jumped around here, I'm sorry. I went to D. to do find the probability of A if B. Okay, remember I told you I was going to write A if B. So the probability of A if B is A and B, 0.20, comes from right there. Divided by the probability of B, well, the probability of B was given at 0.33. So 0.2 divided by 0.33 is 0.61. Then I jumped up to B. I was working at columns instead of rows. Find the probability of not B. Okay, well, here's B, right? 0.33. So I'm going to take 1 and I'm going to subtract 0.33. I'm going to get 0.67. I'm always going to do that contrapositive, if you will. E, B if A. Okay, well, now I just got to turn this one around a little bit, make a small adjustment by dividing by A instead, because the probability of B given A is the probability of A and B divided by the probability of A, which is 0.43. A or B. I had this highlighted because the original paper had an error on the answer worksheet, but yours is okay. Okay. C. The probability of A or B. I'm going to scoot mine up a little bit here so we can all see it. So first thing I did is I took the formula, probability of A plus the probability of B, and I subtract the probability of A and B. 0.47 was A, 0.33 was B, and 0.20 was A and B. If you add these two and subtract this one, you get 0.6. Then the question was, are A and B disjoint? Okay, well, to be disjoint means that there is no overlapping probability. And clearly in the problem, it told me that A and B had a value of 0.2 right here. If the probability of something happening has a value, then they are not disjoint from each other. So the answer is no for letter F. Going to go down to number 21. I'm going to jump a little bit between my paper and this value. So the first thing says, let's find the probability of A. To find the probability of A, you find the column that has A in it. You take 0.21, 0.1, you add them together, you get 0.3. Add them. To find the probability of not B, okay, well, let's find B first. I could do this, clearly. Look, 0.1 and 0.3, 0.4, see it? But watch this. If I take 0.2 and 0.4, that's 0.6, right? And if I take 1 minus 0.6, I still get 0.4. Find the probability of A and B. Go right there. A and B, 0.2. There's no math happening. It's just you finding the columns from the paper. A or B. All right, well, now we got to get a little involved here. Remember, we need the probability of A, 0.3. We need the probability of B, 0.6. And we need to take out the probability of A and B. 0.3 plus 0.6 is 0.9. 0.9 minus 0.2 is 0.7. I wrote that out for you. A or B, A plus B minus A and B equals A or B. Letter E. Find A if B. Okay, so we find the probability of A and B, 0.2, and we divide it by the probability of just B, 0.6. So to find A if B, we take 0.2 and divide it by 0.6, and we get 0.33. The next question says, hey, just turn that around. Take the probability of B given A. 0.2 this time still, but this time the probability of A is 0.3, and we divide it by point and get 0.66. Notice they're not equal to each other. Letter G, are A and B disjoint from each other? Okay, well, the way to figure that out is to go right here and look and see if there's a number. If there's a number here, then the answer is no, they're not disjoint. G is no because the probability of A and B is 0.2. Are the events A and B independent? Okay, well, remember that formula that we had back on our first piece of paper. And when we talked about the true false, I'll go back to it for a second right here. If A times B is the same as A and B, then the events are independent. Okay, well, let's go check that. So remember, the probability of A is 0.3. The probability of B is 0.6. If I multiply 0.3 times 0.6, I do not get A and B, 0.2. Matter of fact, I get 3, 6, 18, I get 0.18. So I get an 18. And an 18 is not equal, a decimal, is not equal to a 0.2. They're not the same with each other. And I got to move a decimal actually in there. Last one, 22. Find the probability married if less high school, okay? So I'm looking for the probability of M if high school happens. Okay, so I need two things here. First of all, I need this and this happening together. So I need, here we go, less high school, married, that was 70 things out of 665. Here is the probability of M and HS right here. And that's right here. Okay, and it's divided by 665. Secondly, for the bottom, remember, I need the probability of just less high school. So in order to get the probability of less high school, I go to less high school, 125. 125 out of 665. So this is the probability of being just simply whatever education level is, which is less than high school. 125 divided by 665. I put this into my calculator, 70 over 665 divided by 125 over 665, and I get a probability of 0.560. I'm going to end the recording for P1 section, and when I come back, I will do the chapter 4 section for you.